Hi everyone, today we will be learning about solving one-step inequalities by using addition. Well, what in the world does that even mean? Well, it means the same thing as when we solved one-step equations, except we will continue to use the inequality symbol, either less than or greater than or equal to, and solve and graph the same way that we did using the closed dot or the open dot in our last lesson. So solving one-step inequalities, the first thing we're going to do is start with a problem that looks like this one. X minus 5 is less than -3. So our job to solve this problem is first to draw a balance line. So our first job is to draw a balance line. Typically, we would draw the balance line in the equal sign. However, we don't have an equal sign. And our goal here is to isolate that variable. So we want to isolate the variable. We want to solve for x. That is our goal. So we're going to do that. We're going to start first by drawing a balance line. And what we do to one side, we're going to do to the other. So we want letters on one side and numbers on the other. So we want to move all the numbers from here over to here. So thinking about addition being the opposite of subtraction. So we want to add 5. When we add 5, this zeroes out and goes away. And what we do to one side, we're going to do to the other, just like we do when we're balancing equations. Our x is going to drop down. And now we have -3 plus 5. Well, if I had -3 in the bank and I deposit $5, that means that I have 2 left over. So my equation now says x is, and it's not equal, we're going to use this symbol. So we're going to come back in now and we're going to just change this symbol to less than 2. So this tells us that in order for this equation to be true, or this inequality to be true, x has to be less than 2. So the different things that x can be in order for it to be less than 2. Where is my... Oh, I lost a pen. Well, that's a bummer. I wanted to use my same pen that I was using for making my number lines. So we're going to make a number line, just like we have in the past. And on my number line, we're going to graph 1, 2, 3, 1, 2, 3, 4. All right, so it says that x has to be less than 2. Now, it is an open dot because it's not going to equal 2. We're going to use an open dot. So I'm going to find 2. Here's 2. I'm going to put an open dot, and it's everything less than 2. So my arrow goes to the left because it is open dot to the left, less than 2. All right, sorry about my dog barking. Let's do another example. Another example here. So example B. Example B, this one says x minus 2 is greater than or equal to -4. Okay, so again, the goal is to isolate that variable. So we want x's on one side and we want numbers on the other. So let's go ahead and we're going to start by drawing our balance line. What we do to one side, we then have to do to the other. So opposite of subtract 2, we're going to add 2 and add 2. This is going to go away. It zeroes out. My x can now drop down. It is greater than or equal to, I had -4, I add 2, so I have -2. So now we're ready to graph this. We know that when it's equal to, it's going to use a closed dot. So again, we're going to have our number line. And this is saying all solutions that are greater than or equal to -2. So anything that's bigger or the same as -2. So let's go ahead and it can be equal to -2, so we can use a closed dot. And it's everything greater than or larger than -2. So our arrow is going to point to the right. Greater than. So this means that our solution could be -1, it could be 4, it could be 5, it could be 292, could be any of those numbers. We don't know because it's an inequality. All right, our next example is example C. And example C says that we want to solve x minus 4 is less than or equal to 3. Less than or equal to 3. So again, we're going to start out by drawing our balance line. What we do to one side, we're going to do to the other. So instead of we want x's on one side, we want numbers on the other. That is our goal, to isolate this x. So we're going to do the opposite, which is add 4, and do the opposite, which is add 4. So this says x is less than or equal to 7. So x is less than or equal to 7. Okay, now that we know that the solution for x is going to be less than or equal to 7, we are going to go ahead and draw a number line. And then we're going to graph it on the number line. Okay, so now, again, it's equal to, so it's closed dot. It's equal to 7. It's a closed dot, but it is everything that is less than. So it's going to keep on going forever. Closed dot, less than. All right, it is your turn now to do a try it or two. So I'm going to go ahead and turn the page now so that you can do your try it's. All right, try it number 1. Okay, try it number 1. It says y minus 6 is greater than -7. And try it number 2. Try it number 2 says b minus 3.8 is less than or equal to 1.7. 1.7. All right, go ahead and do your try it. Again, it doesn't matter about the letter. It can be any letter as long as you solve it. So we want letters on one side, numbers on the other. Go ahead and hit pause right now so you don't hear me solving. And then when you're ready, come on back and hit play so you can check your work. All right, I'm going to draw my line. I want to isolate this variable. I want y by itself, so I'm going to do the opposite. So minus 6, I'm going to add 6, and add 6. So that goes away, and that is y is greater than, I had -7, I add 6, so I have -1 left over, so y is greater than -1. So if I were to graph this on my number line, y is greater than -1. It doesn't equal -1, so it's an open dot, and it's greater than, meaning it goes to the right. So it's all the solutions to the right. Okay, let's try number 2. Number 2, we're looking again, draw our balance line. We want b on one side, numbers on the other. So opposite, we're going to add 3.8 and add 3.8. So 7, 15, 1. So carry the 1. So we get 3, 4, 5, 5.5. So b is less than or equal to 5.5. Less than or equal to 5.5. So again, to graph this, we're just going to draw our number lines. We're going to have our 0, 1, 2, 3, 4, 5, and 6, -5. All right, so we want a closed dot at -5.5, which is right in between 5 and 6, and then it includes everything that is less than, so our arrow to the left for less than. Everything less than 5.5. All right, how did you do? Go ahead and answer your essential question. Answer that essential question now. How do you solve one-step inequalities using addition? How do you solve one-step equations or inequalities using addition? And then put your level of understanding out to the side. Where are you at? If you need help, come on back to the Google Meet and ask for help. Otherwise, you can go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.